Okay, so good day everyone. Our topic for this video is all about the circular functions. So the circular functions are sine, cosine, and tangent. And we have the so-called basic trigonometric ratios and the reciprocal ratio. So when we say basic, we have the sine theta, cosine theta, and tangent theta. While the reciprocal ratios are the sine theta, its reciprocal is cosecant theta because the sine is opposite over hypotenuse. Then the cosecant, the reciprocal of opposite over hypotenuse is hypotenuse over opposite. Then cosine theta, its reciprocal is the secant theta because adjacent over hypotenuse for cosine, the secant is hypotenuse over adjacent. While the tangent theta, its reciprocal is cotangent because tan is opposite over adjacent, then cotangent is adjacent over opposite. Okay, so let us now explore, but to go deeper about trigonometric ratios, it is very important to know the special right triangles theorem. So what are the special right triangle theorems? We have the special right triangles. So the first one is the 30, 60, 90. So what is being mentioned in the 30, 60, 90 right triangle? It says that the opposite of the 30 degrees angle, so as you have seen, we have this, the 30 degrees angle, its opposite is the shortest side, while the longer side, which is opposite the 60, so this is the opposite side of the 60 degrees angle, and this is said to be the longer side. And of course, a right triangle has its longest side, the so-called hypotenuse. So it says that the hypotenuse is twice the shortest side, meaning the shortest side is one half of the hypotenuse. Again, the shortest side is one half of the hypotenuse, or in other words, the hypotenuse is twice the shortest side. While the longer side, whatever the shortest side measure, we will always multiply its square root of 3 because it says in here, uh, the opposite side of the 60 degrees angle, this is the 60 degrees, and then its opposite side, because remember guys that every angle is always opposite to a side. No angle that ang ihang opposite is also an angle. So the hypotenuse is twice the shortest side. So whatever the shortest side, you just multiply it to the square root of 3. So that's the first special right triangle theorem, the 30, 60, 90 right triangle theorem. And the other one is the 45, 45, 90, and this is said to be the isosceles right triangle because isosceles right triangle is a triangle where two sides are congruent. So as you have seen in here, the blue text or the blue sides are said to be congruent. So when we say congruent, they are equal in measure. So if this is leg, this is also leg. If this is 1, this is also 1. And it says that the hypotenuse is square root of 2 times the measure of the legs. Meaning, if the leg is 2, the hypotenuse will be 2 square root of 2. Okay, so again, if ever the leg will be somewhat 3, the other leg is also 3. And since the hypotenuse is leg times square root of 2, okay, it is mentioned here that square root of 2 times the measure of the legs. So since the legs is 3, thus the hypotenuse of a 45, 45, 90 degree theorem is always leg times the square root of 2. So now we are going to recall the 6 trigonometric ratios, this one, and on the okay, so let us have this example in applying the 6 trigonometric ratios. So as you have seen, we have here a right triangle with the measures of the hypotenuse, which is 18, and the 9 as the opposite of the angle beta, and the 12 is adjacent to the angle beta. So the first thing to consider is we are going to label, no? So where is the angle beta? So this is said to be our reference angle. So if that is our angle beta, what is that 9 to the angle beta? Of course, this is opposite to the angle beta. And remember that side is the longest, so this is the hypotenuse. if that is the hypotenuse, the 12 there is adjacent to angle beta. Now, we are done labeling the adjacent side, the opposite, and the hypotenuse side. So, it will be now easier to determine the 6 trigonometric ratios. So, for the sine beta, remember the mnemonic device, su, ka, tuwa. So when we say su, refers to sine, opposite over hypotenuse. So opposite, what is opposite to the beta? It's 9. Hypotenuse, it's 18. So the 9 over 18 can be reduced to 1 half. So meaning sine beta, according to the sides of opposite and hypotenuse, that will be 1 half. The next is cosine beta. So the cosine beta is expressed into ka, adjacent over hypotenuse. So adjacent, where is adjacent? So the adjacent side is 12, the hypotenuse is 18, and this can be reduced by dividing by 6. 12 divided by 6 is 3, and 18 divided by 6 is uh what is this? 12 by 6, I'm sorry, this will be 2. This is 2, and 18 divided by 6 is 3. So 2/3 is the simplest form of cosine beta, while opposite over adjacent for tangent. Opposite to theta is 9, while adjacent is 12. And this can be reduced by dividing both by 3. 9 divided by 3 is 3, and 12 divided by 3 is 4. So therefore, these are the trigonometric ratios of the basic function. Let us go now to the reciprocal. So cosecant beta, remember, in here is 1 half. You just simply reciprocate the 1 half and it's 2. And then the hypotenuse over adjacent secant is reciprocal to cosine. So the 2/3 is being reciprocated. It is now 3 halves. While the cotangent beta, the reciprocal of 3/4, because cotangent is the reciprocal of tangent. So it's 4/3. Now, guys, it is very easy to determine correctly the basic trigonometric ratios so as to get the correct reciprocal trigonometric ratios. Let us now have another example. Let us try this. Instead of angle beta, we have now theta. And this is now being represented, the sides are being represented by letters A, M, and N. Now this is to be familiarized. Now, where's the adjacent side? And of course, if this is the theta, this will be the adjacent side. This is the adjacent. Never masad na nganlan nimo og opposite, because the opposite to theta is A, while the M is the hypotenuse. Hypotenuse, M is the longest side, and this time we will be getting the basic trigonometric functions according to the sides A, M, N. So sine, opposite over hypotenuse. So where's the opposite to the theta? It's A, represented by A. Hypotenuse is M. While cosine, adjacent over hypotenuse, it's N over M. While the tangent, opposite, which is A, so the tangent is opposite over adjacent, so that will be A over N. Now let us go now to the reciprocal, and I'm sure they are corresponding to the reciprocal function. So very easy. You just simply reciprocate the basic, no? So this is A over M, so this is M over A. And second is N over M man ang cosine, so this will be M over N. While the tangent is A over N, this will be N over A. So I hope you already familiarize as to how to get the 6 trigonometric functions, the basic and the reciprocal, in such a way that you will be familiarizing the different sides as to how it is being related to the theta. If it is adjacent, if it is hypotenuse, or if it is opposite. Okay? So now I want you to try recall the special right triangle theorem, which is the 30, 60, 90 and the 45, 45, 90. So let us try uh, recall that the 30, 60, 90 is being represented by this figure, that the 30 degrees, it is always opposite to the shortest side, while the 30 degrees, its hypotenuse is always twice. I'm sorry. Again, the hypotenuse is twice the shortest leg, while the longer leg is shorter leg times the square root of 3. So therefore, uh, giving you this is I want you to relate this later to your uh, scientific calculator as what is the sine of 30, cosine of 30, tangent of 30, as well as the reciprocal functions of that 30 degrees angle. And I want you to try compare what is sine 30 from this illustration and what is that sine 30 in your scientific calculator. Now let us try. Sine 30, so the 30 degrees is our reference angle. So sine 30 is opposite over hypotenuse. So sine 30, what is opposite to sine 30? It's 1. So the SOHCAHTOA is being repeated as to let you memorize. No? So sine 30, opposite over hypotenuse. So what is opposite? 1. And then what is its hypotenuse? 2. So to have the table of this 30 degrees angle with the 6 trigonometric functions, the sine 30 is being represented by the ratio 1/2. What about the cosine of 30? Where is your 30 degrees? Cosine adjacent over hypotenuse. So therefore, adjacent is square root of 3, while the hypotenuse is 2. So having it on the table, square root of 3 over 2. Let's proceed to the tangent 30. Remember that tangent is opposite over adjacent. So what is opposite to 30? It's, no, the adjacent of 30 is square root of 3 and its opposite is 1. So having it on the table, we have 1 square root of over square root of 3. Now for the cosecant of 30, remember the reciprocal of 1/2 is 2 over 1 or it's 2. Secant 30 is the reciprocal of cosine 30 and it's 2 square root of 3 over 2. Then reciprocating it will be 2 over square root of 3. But the question, where did we get that 2 square root of 3 over 3? Now remember guys that the secant is the reciprocal of cosine. So we will be reciprocating this. So unsa may reciprocal ana, di ba? 2 over square root of 3. What is the law of radical? The law of radical says if the denominator is containing a radical expression, it remains unsimplified. So kay unsimplified man siya, ato siyang isimplify. So how to simplify this? Remember that we will be looking for a fraction which is equal to 1. Because remember that 1 multiplied to any number, the result is tilde number. Walay mausab kung ang 1 i-multiply nimo sa any number. But how to choose that fraction which is equal to 1? Remember guys that 3 is our radicand. Ang atong index kay square root of 3 man na siya. So, ang atong index is 2. Meaning, we will be having the multiplier as square root of 3. Whatever your denominator will be also your numerator so as to give us the result of 1. Square root of 3 divided by square root of 3 is equal to 1. And why square root of 3, not square root of 5, not square root of 6? Why? Because we have a radicand here, 3, and remember this is understood an exponent of 1, and this is also having an exponent of 1. So go back to the multiplication of radical. 2 times the square root of 3, ato na gihapong kapihon ang 2, then kapihon ang square root of 3. Nga naman, they are not same nga radical expression. 2 is a whole number and square root of 3 is a radical, so it remains a coefficient. The 2 there is the coefficient of square root of 3, and this time we will be also multiplying both denominators. In multiplying the denominators and they are containing radicals, we will simply copy the common index. Remember the common index? it's 2 here and 2 because this is square root. So meaning it's understood that there is a 2 in there, invisible or imaginary. So multiply now the radicand. When can we multiply the radicand? If parehas sila og index. So kay pareha man sila og index, copy the common index. 3 times 3 is 9. So this time, that will be 2 square root of 3 and then over what is the square root of 9 man? So 3. So this time our denominator is no longer containing a radical. So therefore that is why the second 30 is 2 square root of 3 over 3. So I hope nasabtan nga nung na 2 square root of 3 over 3. So the most important thing guys is you know how to or your stock knowledge about radical expression or simplifying radicals. What about that cotangent 30? Cotangent 30 is the reciprocal of tangent. So meaning the cotangent is 1 over square root of 3. Then the reciprocal of cotangent 30 will be, and I'm sorry, the reciprocal of 1 over square root of 3 is square root of 3. So therefore, this will be also square root of 3. Okay, so to proceed, we are going to have now the 60 degrees angle and having the basic trigonometric ratios and the reciprocal trigonometric ratios of the angle 60 degrees. Okay, so first, we are going to get the sine function. The sine is opposite over hypotenuse. So opposite over hypotenuse, but I'm sure we have already correctly labeled this is the 60 degrees. So of course, this is the adjacent. This one is the adjacent to 60, and of course the opposite to 60 is square root of 3 because this is the longer leg and the hypotenuse is always twice the shortest leg, so this is 2 as our hypotenuse. So therefore sine 60 opposite over hypotenuse. So what is opposite to 60? It's square root of 3. And what is hypotenuse? It is 2. And then we have to have it on the table. Square root of 3 over 2. Sine of 60. We have squared 3 over 2. Then the next is cosine of 60. Cosine function is adjacent over hypotenuse. So what is adjacent to 60? So it's 1. What is hypotenuse? 2. Let's proceed to the tangent function. Tangent function is opposite over adjacent. So tangent 60 opposite. What is opposite to 60? Square root of 3. And what is adjacent to 60? It's 1. Okay, so done with the basic trig functions, we will go now to the reciprocal. And remember, the reciprocal of square root of 3 over 2 is 2 square root of 3 over 3. Now question, why we're able to have the reciprocal of square root of 3 over 2 into 2 square root of 3 over 3. So let us try check. Remember guys that when square root of 3, that's 1, square root of 3 over 2, that is square root of 3 over 2, we will be reciprocating it because we will be getting the cosecant. So that will become 2 over square root of 3. This is already the reciprocal. But we will not consider this as our final cosecant if you are asked to determine the reciprocal of the given if it is still containing a radical in the denominator. So the reciprocal is 2 over square root of 3 is not yet final because the denominator is containing a radical. So we will be multiplying it by a fraction which is equal to 1. And of course, we will be choosing square root of 3 over square root of 3. Remember, square root of 3 over square root of 3 is equal to 1. And why we are choosing square root of 3? Because our given denominator is square root of 3, so this will become multiplied to square root of 3. That will be 2 square root of 3. And then square root of 3 over square root of 3. Square root of 3 times square root of 3 will be square root of 9. And then what is the square root of 9? 3. So therefore, that is why we were able to get this reciprocal of sine 60 as 2 square root of 3 over 3. Okay, what about second 60? The reciprocal of cosine 60 is 1 half. So of course it's 2 over 1. And what is 2 over 1 simplified form? So, or it could be answered 2. And then what about the cotangent 60? The cotangent 60, guys, is the reciprocal of square root of 3 over 1. And what is its reciprocal? The reciprocal of square root of 3 over 1 will become 1 over square root of 3. Again, the denominator is containing a radical, so we will be multiplying it by square root of 3 over square root of 3. So 1 times square root of 3 is square root of 3. Square root of 3 times square root of 3 is the square root of 9. And the square root of 9 is 3. That is why the answer for this is square root of 3 over 3. Okay. So again, this will be square root of 3 over 3. Okay, so to continue, we have the last, which is the 45 degree angle. So we have the triangle with the 45 degrees. So we will be getting the basic trig ratios in the reciprocal functions. We are going to get the sine of 45. So sine is opposite over hypotenuse. So this is our 45 degrees angle. And we have the opposite, which is 1. So our opposite is 1. This is the 45 degrees and its opposite is 1. And what is our hypotenuse is the square root of 2. Okay, so 1 over square root of 2, remember this is not simplified yet because we are going to simplify the denominator. So if it is 1 half, it is 1 over square root of 2, we will be getting its multiplier, which is equal to 1. So 1 square root of 2 is the square root of 2, and then 2 times 2 will be 4, and copy the common index square root of 4. So what is the square root of 4? So we have the positive 2. Okay, so we have square root of 2 and the square root of 4 is 2. And that is why the square root of 2 over 2 is the sine of 45. Okay, next, the cosine of 45 will be adjacent over hypotenuse. So adjacent over hypotenuse. So what is our adjacent to 45 degrees angle there? So adjacent is 1. Adjacent is 1. The hypotenuse is the square root of 2. Still remember that we are having 1 over square root of 2, and simply it is just the same if you're going to simplify it because uh, the sine of 45 is still 1 over square root of 2, and we simplified it by square root of 2 over 2. So cosine of 45 is still square root of 2 over 2. What about the tangent of 45? Tangent of 45, opposite. What is the opposite of the 45 degrees? It's 1. And what is our adjacent? 1. So tangent of 45 is equal to 1. So it's 1. Guys, if you would like to use your calculator getting the sine of 45, you press sine, you press 45, you will be getting square root of 2 over 2 in radical. And what is the equivalent decimal equivalent of square root of 2 over 2? So then you will be relating the sine, the cosine, and the tangent functions in your scientific calculators, and then soon we will be relating the 6 trigonometric functions to the unit circle, because I am sure you will be wondering where did this unit circle points on the unit circle coming from. Especially you have known that the unit circle is made up of infinite number of points, and why are these coordinates are made up of square root of 2 over 2, square root of 3 over 2, and so on and so forth. So tangent of 45, pressing your calculator, it will be giving you a 1. So now you can now relate that the special right triangles theorem are of very useful in uh, getting the 6 trigonometric functions. So the cosecant of 45, hypotenuse over opposite. So square root of 2 over 2, reciprocal of that will be 2 over square root of 2. Again, simplify it. Square root of 2 over 2 is our multiplier. Ngano gani ato siyang i-simplify kay dili man siya simplified kung ang iyang denominator is containing a radical. So multiplier square root of 2 over 2, square root of 2 over square root of 2 is always equal to 1. So multiply both numerator as to simplify it further. And square root of 2 times square root of 2 is the square root of 4. And then 2 square root of 2, what is the square root of 4? 2. That is why 2 and 2 will be cancelled because it answers 1. So therefore, the answer of cosecant 45 is the square root of 2. Next is secant 45. So, parihara man si sine 45 o cosine 45 square root of 2 over 2, meaning ang secant 45 is still square root of 2. While the cotangent 45, the tangent 45 is 1, and of course, the reciprocal of 1 is of course 1. So therefore, if we are going to have the table of the of the 45 degrees angle, the 6 trigonometric functions of 45 degrees angle, therefore, there is the table of the 45 degrees angle, the 6 trigonometric ratios. Guys, I hope you've learned something from my video. And of course, if you will be learning, I hope you will also do subscribe my channel. It will be my pleasure. Thank you and good day everyone, that in all things God may be glorified. Bye-bye, and this is Sister Justina. Say thank you for watching.